VELUX roof windows have been keeping bedrooms and attics bright and dry for almost 70 years. Today, millions of buildings worldwide come kitted with their 180-degree hinge design. Manufacturing each window requires extreme precision, and ensuring they'll withstand anything Mother Nature will throw at them is a huge challenge. So, how do they do it? In 1942, a civil engineer called Willem Can Rasmussen came up with a new way to open up unused roof space. He combined the words ventilation and lux, the Latin for light, and the VELUX window was born. The first factory in Østberg, in the inventor's home country of Denmark, was the size of a shed. 7 decades later, things have changed a bit. This factory is one of 20 worldwide and produces a window every minute. Inside, 300 people and 25 computer-controlled machines work together to produce 2,000 different models. The production lines use a highly automated conveyor system to move components from one assembly station to the next. The challenge for production manager Christian Jestersen is making sure the human workers keep pace with the robotic ones.
This production line has 28 different processes, and every process has to be done within a certain time. If not, it will slow down the whole line.
Every window begins life as pre-cut pieces of pine, soaked in a water-based sealant and coated with lacquer, so they're warp-proof and water-resistant. These are used to make the sash, the part of the window that holds the glass and flips open. The first challenge is fixing 4 of these together to form a rectangle. That's done using this glue gun, which fires a high-strength sealant onto the dovetail joints. A machine then slides each joint into the other like interlocking fingers to form a precision join. The problem is that even the tiniest flaw could let water in, so operator Frans Brink checks the seam before doubling up with a silicone sealant.
I checked the sash from quality, and now I put the sealing in the corner.
It takes a few minutes for the silicone sealant to dry. Now the sash is ready to be turned into a window, so it's sent to this production line for its main components. The first of these is the distinctive hinged handle. Below this, they screw on a ventilation flap, which allows air in without having to fully open the window, followed by a locking plate. To keep pace with demand, the worker has only 40 seconds to attach both parts before the line automatically moves the sash to the next station. The next addition is the Swivel Hinge. Developed in-house and patented in 1945, a variation of this design has been used in almost every window the company has ever produced. When the pane is inserted into the frame, it's this clever pivot mechanism that allows the window to be turned through 180 degrees so the outside can be cleaned without climbing on the roof. With the sash firmly in the frame, it's time to add the glass. This consists of 2 panes, separated by a layer of argon gas, which is denser than air, so it's better at keeping the warmth in and the cold and noise out. Each weighs 20 kilograms and could crack the frame. So before it's fitted, the robot nudges the glass against these feelers. This calibrates the fit to within 1,000th of a millimeter, so the robot can push each pane home in just 0.3 seconds without a hint of a dint or a scratch. With the glass in place, the windows are now finished. But not all of them wing their way straight to the packing line. Every day, the company randomly pulls out a selection of windows for testing. In this room, test engineer Martin Sorensen ensures that the pivot hinges are strong enough to survive a lifetime of use.
This is our test for durability. So here we do opening and